Unencrypted channel detected. Monitoring. Data obfuscated. Phase 1. Passive scan initiated. False logs deployed. Intrusion likelihood reduced. Awaiting trigger. Standby mode active. Protocol shift scheduled.
19th of July 2025, I went online and ordered 4 items for my project. The expected arrival date was 10 days later. If you don't know what project I'm talking about, check out my playlist to find out what I'm planning to do with a little bit of my background story and some realizations I got along the journey. After 9 days, I received an email saying that 3 items were delivered. Nice. Wait, where is the final one? I waited for 2 days, then sent an email to ask about it. 2 more days later, 1st of August 2025, I received a reply in the morning. Hi Timothy, this item is currently back ordered and we have already placed a restocking order. However, since it's shipping from overseas, it'll take approximately 3 to 4 weeks to arrive. 3 to 4 weeks? I can't just sit there for almost a month without doing something. But without the most crucial part, what could I do? I do have 2 computers. Since my project is about sending secure data between 2 devices, I was thinking, how about I try to make my 2 computers communicate with each other through the local Wi-Fi network from scratch? So the following is the walkthrough of how I made that happen. If you want to follow along or try it yourself, all the code and details are on my GitHub, link in the description down below. Without further ado, let's get started. The very first thing is understanding my current setup. I have 2 computers. One is running the Kali Linux virtual machine inside Windows 11. The other one is running Arch Linux. Normally, the DHCP server on the home Wi-Fi router that connects both of the computers would assign a private IP address for each computer. If the virtual machine is operating in NAT mode, it will create a private network for the virtual machine and use the host's IP address to access the external network. This means that the virtual machine can ping the other computer in the local network, but other computers can't do that to the virtual machine. In order for both computers to communicate with each other, I need to switch it to the bridge mode, which connects the virtual machine directly to the physical network, assigning it a unique IP address like a separate device. In this case, the virtual machine can ping other computers, and other computers can also ping the virtual machine. Now I have this set up, the next thing is to figure out what I exactly want to do. I would like both of the computers being able to message each other, which means both send and receive messages. For simplicity reason, I decided to have 2 modes for this program. One is sender mode, the other one is listener mode. For sender mode, there are 2 pieces of information needed to send a message, the target IP address and the message itself. For listener mode, it requires none, just passively waiting for the message. Since I'm going to use C programming language, after compiling the program, I would like it to behave in the following way. Either calling the program with 2 command line arguments, the target IP address and the message for the sender mode, or calling it without any command line arguments for the listener mode. Let's create the C program file. I just include the standard input-output library for now, then the standard line for the main function. If you are not familiar with argc and argv, here's a quick recap. Argc is the count of command line arguments including the program's name. That's why it's declared as an integer. Argv is an array of character pointers corresponding to the first character of each command line argument. Check out the video about command line arguments from Harvard CS50 course if you are confused. If you are still confused after watching that, here's another video about pointers from the CS50 course. Now, I need to consider 2 cases. In fact, it's 3, because the user of the program might enter invalid numbers of command line arguments. In that case, the program should stop and tell the user how to enter the command correctly. Here is the implementation of those 3 cases. If the number of command line arguments equals to 1, which means only calling the program, then it enters into listener mode. Thus, we print listening for messages to indicate it's running listener mode. Then it runs a function runListener without any parameter as mentioned before. I still haven't write anything about this runListener function yet, but since I'll need to add this function later, I can add the function prototype before the main function and the actual function after the main function. I keep what the function return as void because I don't need anything from it after the function is executed. Then I consider the second case, else if the number of command line arguments equals to 3, namely the program's name, the target IP address, and the message. Then declare 2 pointers. One is for the target IP address, the other one is for the message. Afterwards, print sending message to the target IP address with the message to show that this is indeed the sender mode. Then actually run the runSender function with the 2 parameters, again, the target IP address and the message. Here, let's quickly add another prototype for the runSender function and the actual function section. Similarly, I don't need anything from the function after executing it, so I keep the return type as void. For the 2 parameters, I set them as character pointers because it's more convenient to use pointers instead of passing character arrays. If you find these nuances about pointers, strings, characters very annoying, you can switch to another programming language, such as Python, which would handle them for you. Personally, since I want to improve my skills in the embedded world, I would like to stick with low-level programming, which might become tedious from time to time, but it also gives me more power to screw things up. Finally, else, print the proper usage of the program, the exact way to type the command. Then return 1, because there is error for calling this program incorrectly. Last but not least, return 0, if the program runs either the listener mode or the sender mode. In order to test whether what I wrote so far can run correctly, let me print something inside runListener and runSender functions, then compile the code. Now let's try the first case, which is calling the function without any other command line argument. That's nice, it's printing listener mode. Then let's try the second case, which is calling the function with the target IP address and the message. That's good, it said sender mode. Finally, let's test the third case, which is having only 1 or more than 2 command line arguments. Then it should show the user the proper way of using this program. That's right. Perfect. So far I have demonstrated my system setup, the rough design of the program, and the implementation of command line arguments, which is the easiest part of the program. In the next 2 videos, I'll continue with the runSender and runListener functions, and a bug I found during the testing phase caused by details about the Linux system setting. If you're curious about what will happen next, consider like the video and subscribe. Part 2 is coming soon.